This talk is going to be split into two parts. We'll leave it down here because Zach's going to come up. All right. Zach is the other part, my undergraduate research student who's helped me with the data analysis on this. He's shorter than I am, so we'll keep the mic low. This work has been going on for about 9 years, entirely on San Salvador. It's kind of a work in progress, and so each year the project morphs a little bit along the same lines, but we've been slowly defining the part of the projects that are really becoming important to us. And one of those issues is the fire ant problem. Those of you that live in the Bahamas, those of you that live in Florida or Georgia, in the southern states are very familiar with fire ants. They are not particularly pleasant. There are many, many fine researchers in the University of Florida, South Florida, and Georgia that all study fire ant biology. It's quite an important area. So the question I'm going to try and address here today is this something Bahamas should worry about, could do anything about? We have enough knowledge about fire ants where we can actually get some ideas about how to mitigate this problem and to know where the problem is actually going to lie. So outline briefly, I'm going to talk about fire ants, the what and why, a little bit about competitive interactions among ants, which is really my interest. The fire ant impacts on community, we'll talk a little bit about that. And then Zach will take over and he'll talk about how we monitor them, what the results of our work were, and then I'll come back up and give away all the answers. Okay, so Solenopsis invicta. There's basically two fire ants that you guys might care about in this area. That's the Solenopsis invicta, which is the red imported fire ant from Argentina. And then there's another species called Solenopsis geminata, which is the tropical fire ant. I actually think the tropical fire ant hurts a little bit more when it stings you, but the nests and so forth tend to be a little bit smaller with the tropical. There's a small question, too, is whether should the tropical actually be here or not. I've been talking to some of the people like Wetterer that study invasion of ants throughout the Caribbean. Most people believe that it's actually been introduced to the Bahamas. So the basics about the life history of fire ants, introduced from South America, thank the United States military and trade. Between the two, they've ensured that fire ants are everywhere in the Caribbean. So 1890s in the United States are the first records. It was probably there a little bit earlier than that, spreading from places Mobile, Alabama, and Louisiana up into the rest of the southern states. The nest biology is interesting in that the most invasive forms tend to be polygamous or polygynous, where you have multiple queens occupying the same nest. This is a common thread for invasive organisms because you're necessarily creating a bottleneck. Fire ants, Argentine ants, other invasive ant species, your biggest competitor is always a conspecific. They want the exact same nesting area, they want the exact same food, and they want the exact same mates. However, if you're introduced, if a single colony ends up on an island, they're all sisters. So they lose this competitive issue, and so they all just get along. You can pick up fire ants from one polygynous nest and drop them in the next one, and they'll just be fine and go, okay, I'll go work for you guys, because they literally are sisters. And so that leads to the real invasive issue. You can get massive, massive densities of these nests because they're not competing with each other. They're all kind of working together. Some of these ants, like the Argentine ant, Linapitha humuli in California, it is a single super colony stretching all the way from San Francisco down through San Diego into northern Mexico. It's a single contiguous colony. They're all happy with each other. Where do you find fire ants? Water. If you want to get rid of the fire ants in your lawn, you can stop watering it. It's that simple. In Georgia, I love making this point to people because there's a visceral thing for fire ants in Georgia. They hate them. And it's like, well, stop taking care of your lawn, and your fire ants will go away. Then you'll have ticks and other things in your yard, but that's all right. Next to roads, and this gets to our Kirtland warblers, and the whole time that I think it was David was talking about that, I was just thinking, that habitat that your warbler love is also the habitat that the fire ants love. So there's always, that's why ecology is so interesting. The connections are huge, and to make one decision, you're often having to sacrifice on some other decision. So disturbance is crucial for these guys. Many studies recently have shown that you get fire ants where people are messing with stuff. And if you stop messing with it, they actually get pushed out. Okay? And we'll talk about that a little bit later. Removal of native ants assemblages. Walter Schenkel, I think he's at Florida, he might be retired now, spent a lot of his career looking at why did the fire ants do so well in southern United States? And it was the pesticide companies. We used blanket pesticides and killed all of the native ants, and then the fire ants just had a field day. That march up into the United States would have been a very slow march if we hadn't cleared the way for them with pesticides. A little bit about the ants in San Salvador, really brief. Mark Dayrup at the Arcbold Research Station in Florida came down back in the 90s and did some wonderful surveys, basically around the Gerace Conference. Many areas are still unsampled. That's kind of what I've taken over. You can see up in the corner here, these are 3D printed ant traps that I've created that we're just going to test this year. They haven't been out in the field yet. It's really hard to dig a hole in karst. So this is my attempt at getting past that. I can set these on top of the karst and catch ants. New species are unlikely just because we have winged reproductives. They can spread around just like the butterflies. It's not really easy to isolate ant species like beetles, for example. But there are very specialized habitats on these Bahamian islands, and so I'm holding out hope that there's going to be some very special, specific species that are endemic to the areas that we just haven't found yet. And then I already talked about this with the geminata. You'll see slides when Zach starts talking about the data that we've divided into invasive and native. Some of those invasives we're absolutely sure about because they're from Asia, like Longicornis, the crazy ant in your bathrooms and things that runs around and scares people, absolutely harmless to you. But then there's other species like geminata where we're not absolutely 100% certain that they're not native to these areas, so it makes things a little difficult. Okay, briefly, competitive ant interactions, only because it's just fun to talk about ants. What we found in our studies in San Salvador is that we have this basic run of common interactions that occur, the decision ants make when they meet each other over bait. I'm not going to go into the details, but just to give you an idea, some ants just run. They're chickens. They show up, they grab a piece of food, and if anybody else gets there, they leave. Run and fight under certain circumstances, so you just make your best show of it, but then you give up if things don't look like they're going well. Fight always. Solenopsis, that's their fire ants. Ignore, which is really fun. You have some species that just completely ignore the other ants and do their thing. Submission or stealth, so ants will actually like duck down and hide and pretend like I'm not here when other ants show up. They're very fun to watch. The bulldozers, what I call the invicta and geminata specifically, where they just dam the torpedoes, full speed ahead. We don't care how many of our workers die in this fight for tuna. We're just going to keep coming. And they rely on numbers. So even if they're going to lose the battle one-on-one, given enough time, they take it. The fun one that I really love, and I'd love to spend some more time studying it, is this Monomorium ebeninum. This is the bottom one. This is the Dr. Strangelove. This is the doomsday machine. It's this tiny little black ant, and when it raises its gaster, all other ants flee before it. It's really cool. And fire ants can only, you have 10 of these guys on a bait, and they'll hold the fire ants back for as long as they can. In the end, they still lose to the fire ant, which is too bad, because they're cool, and they're native. And so the factors that affect these competitive interactions, numbers at the bait, how fast they get there, and this is what Zach will be showing you data on, is how quick do they show up, how quick do they recruit, how far the nests are from the bait. So if you have a really high nest density, like something like the Solenopsis invicta, that's going to give you that advantage. Even with Dr. Strangelove, with our little doomsday ants, if they lose these other two things, rate of recruitment and nest density, they're going to lose the bait anyway. So in the end, even that doesn't help. Temperature and exposure is something else I'm looking at. How does being in an exposed habitat affect these relationships? Because we do see very specific communities and very specific habitats, and Zach will show us that. Substrate is also interesting. These ants have strategies that allow them to take advantage of things like the moving sands of beaches. Dorimyrmex antillana, a native ant to the Bahamas that I'm actually going to look at more this summer, actually makes little highways. And the decision making that goes into where to turn off the highway to which particular food source is really interesting. And I'm working with some people at Harvard on that this summer, so it'll be interesting to see what we find. The habitats we covered in this study: Palmetto, Blackland, coppice, plantation. We define Blackland coppice really broadly. Pretty much anything that sucks to walk into is that, on San Salvador at least. Plantation is very interesting because these plantations were abandoned 50, 100, 200 years ago, and we're still seeing impacts from that disturbance. So that's something that we're trying to tease apart. All right, and so now I'd like to introduce Zach Parks. He's my research student, and he's going to go over our methods and data. It's the bottom button, middle is the
Got it. Hello, everyone. All right, so our methods were pretty interesting. So we used pecan sandy mixed with tuna and oil. So we figured it would give our ants all their favorite macromolecules: proteins, carbohydrates, and fats. And then we placed baits on 10 3x5 index cards. And so 4 of these cards we watched continuously for an hour at the sites that we surveyed. And we documented all interactions and arrivals and recruitment times. And then at every site we placed 6 cards haphazardly, and we left them for an hour. And then after the hour was up, we would go back and we would sample whatever ants were on the card. And so we would place cards at least 20 feet apart, and as I said, they were placed rather haphazardly. And we've repeated this 34 times so far over 2 field seasons in mid-June, and that's so far, so we hope to do many more collections. And so this is a new method that we're going to be testing. If anybody would like to volunteer, feel free. Oh, come on. All right. But anyway, so this is our results. So we have 136 hours of bait observations over this 2-year period so far. 24 ant species have been observed at the baits, and we've surveyed 26 sites across San Salvador Island. So first we have this average number of species that showed up to those hour baits that I talked about. So what you see here is that in the Palmetto habitat type and the Plantation Habitat type, we have on average about 1 ant species at those hour bait cards. And then when we look in the Blackland habitat, we see significantly less. And one of the reasons why is because in the Blackland habitat type, often what we would see is when we would go back to those cards after an hour, there would be no ants present. And although that did happen in the Palmetto and the Plantation, it happened much less frequently. And so these are the average number of species at those baits that we observed for the hour. So what you see here is, again, you have about 1 in the Palmetto and the Blackland. And then in the Plantation, you have 1.9. So we thought, that's kind of interesting. But then we did biodiversity and evenness statistics. And what we saw is that the Plantation habitat type was actually contained less diversity in ant species than the Blackland and Palmetto habitat types. And we see even with our evenness statistics that it wasn't a perfect spread for species, so we didn't see every species equally. So what that told us about the Plantation was that that average of 2 species we were seeing at those baits that we were recording for an hour and observing for an hour was most likely the same 2 species pretty much every time. And then what we were kind of most excited about was this percent of native ants and invasive ants at the 3 different habitat types. So what we see is overall we had this pretty even ratio of 49 to 51, 49 native to 51 invasive. And Palmetto is still kind of even there, but then once you get to the Blackland habitat type, we see we have 63% native species and 37% invasive. And then when we move into the Plantation type, we see the complete opposite happening. We have 33% native species in the Plantation habitats and 67% invasive. So then, like Dr. Kjar talked about, this is this time of arrival and time of recruitment. So what we did is we would look and we would say, okay, that's an ant, it showed up, what time is it? And then sometimes the ant would leave and it would come back several minutes later with some other friends, some other sisters, and we would call that recruitment. And we would record that time as well. So what we did was and all these values are transformed with the natural log. So what we did was we calculated this average time of arrival per habitat type. And that's what this x-axis is here. So what you see in the Palmetto habitat type here is Brachymyrmex obscurior down here is he's showing up rather fast, faster than average, and he's recruiting somewhat slow. And then Dorymyrmex antillana that Dr. Kjar talked about as this beach ant is showing up relatively quickly and recruiting relatively quickly. And all the ants to your left are native ants, and over here are invasive ants. So what you see with the invasive ants is this really fast Paratrechina longicornis, and then Solenopsis invicta is also recruiting very fast. Then when we move to the Blackland habitat type, we see these native ants we see more of them. We see more species here represented. And we see them, Brachymyrmex obscuriors taking a little bit more time to get to the bait. And then we see these other ant species, Antillana, Monomorium evaninum, that are recruiting much faster and are arriving much faster. And then in the invasive ants, we don't see any Solenopsis invicta. We do see Solenopsis geminata, but that was one of those weird ants that Dr. Kjar mentioned. And then Paratrechina longicornis he's doing his thing. And then when we move to the plantation habitat type, what we're seeing is that these native ants here, they're there, and what they're doing is they're getting to the bait really quickly, and they're usually not recruiting, except for Monomorium evaninum, which we've already discussed has this pretty cool competitive behavior. And then the invasive ants, like Solenopsis invicta, is getting there rather quickly and is recruiting rather quickly. And then you have some ants here, like Solenopsis globularia, which there really wasn't many encounters with globularia. So what you're seeing here is a sample size problem. And so I think that it's a good space to turn it over to Dr. Kjar so he can tell you what this all means.
Thank you, Zach. 2 minutes, excellent. That's all I need. So these figures are fun because we can address a lot of different questions with them. We're just tuning them. We finally figured out how to demonstrate these data, I would want to say maybe 3 weeks ago, like 2 days before somebody sent us an email saying we needed to submit our presentation before Friday. But this is wonderful because it was really hard to show. I'm not going to go into why, but it was really hard to show these. And if you can't put your data in a form that's easily interpretable, it's really hard to answer any questions with it. And so we're really excited about this. Our next step with this is going to be to kind of match that sample size with the width of the bars to give us a sense of importance. So there we go. So what I think these show is fire ants have been in the Bahamas for a long time, at least 50 years, at least, probably more like 80. The one question I have remaining to really answer whether they're going to take over is if you let the natural habitat return, does it push the fire ants out? And everything I've seen, because the places where we sample on San Salvador, or even the Blacklands, are incredibly disturbed. And there's no fire ants in them. The Solenopsis invicta, geminata is pretty rare in those Blacklands. And so I would suspect that, yes, so far as I can tell, if you leave it alone, they'll actually get pushed out, which I think is a positive thing. The sad thing, and this only has to deal with tourists for the most part, is that beaches in their perpetually disturbed format are havens for fire ants. And so if you like to go lay on the beach, that's a really good way to collect fire ant stings. And there's nothing we can do about that because it's a naturally disturbed habitat. So it's probably going to end up being the situation where you're going to have fire ants always. If you go and bulldoze a large portion of your coppice, you're going to get them in your backyard too. So that's where I will end. I look forward to the surface trapping, and here are my acknowledgments to everybody that's helped out with this research over the past couple of years. Thank you very much.